Hi guys, this is time for free fall. Now this type of problems are also motion in one dimension, but in this time the motion will be only in the y-axis. That means that the objects will move vertically, upward and downward. Now let's take a look. Here we have some equations that you are already used to it for the problems that we have been solving. Now, for free fall problems, we're gonna do a few changes. As we're just moving in the y-axis, our displacement will be in the y-axis. That's why here we have delta y instead of delta x. And the acceleration, it's going to be free fall acceleration. In case that we're talking about Earth, the free fall acceleration that we have here is negative 9.81 meters per second squared, and that is an implicit given, even if it's not mentioned. Now let's take a look at the equations here. You already are familiar with it, but I just want you to point out that the last equation here for final velocity doesn't include time. This equation is very useful when you need to find the final velocity of an object that is falling down or going upward, could be. And what I want to tell you, is that it's useful when we don't have the time, because the other three equations require to have the time. Now let's take a look at the first problem. We have a free fall sample problem. Jason hits a volleyball so that it moves with an initial velocity of 6 meters per second straight upward. If the volleyball starts from 2 meters above the floor, how long will it be in the air before it strikes the floor? So let's take a look. For this problem right here, we're talking about a ball. That's our object. Now this ball initially is 2 meters above floor, and Jason, as he hits the volleyball, he gives it an initial velocity of 6 meters per second. Now, is it going to be positive or negative? It depends. As we're going upward, we're going to consider the velocity to be positive. When it goes downward, we're going to consider it to be negative. Now, we need to point out the givens. So let's see. Okay, I was highlighting the givens. Now it says the volleyball moves with an initial velocity 6 meters over second straight upward. As it is upward, we're going to consider it to be positive. As it is upward is positive. Now it says the volleyball starts from 2 meters above the floor. So that will be my initial position in the y-axis equals 2 meters. As it is above the floor, we could consider it to be positive. Now, the question is, how long will it be in the air? We're talking about time. Delta time is unknown. And it says before it strikes the floor. So I want you to analyze this. The ball, it's moving initially with 6 meters over second of velocity upward. Then at a certain point it will start to go downward. At this point here, right in the floor, as you can see, I draw a Cartesian plane here. So initially it was at 2 meters, so plus 2. But the final position of the ball is here in the floor, where the position is 0. So my final position here, my y final, even if it's not mentioned, but it just said that it strikes the floor. So the final position is 0 meters. right here. This is the final position where it is 0 meters. Now let's see. We need to find the time. Now from the equations that we have here, the first three, I have the time in it, and I just have initial velocity and two positions. That's it. There's another given that is implicit in every free fall problem, that is gravity. Negative 9.81 meters over second squared. This is the free fall acceleration on Earth. It's a given, guys. On Earth, if we change planet, we need to change gravity too. Now, the only formula that is useful in this point is this one. Why? Because we don't have time, that is unknown, but if you find the velocity, with this other equation, we'll be able to find the time. So let's see what happens. Final velocity equals square root of initial velocity to the second power plus 2 gravity delta y. Now, delta y, what is it? Delta y represents a change in position like we learned in class. So this is y final minus y initial. My final y is 0 meters and my initial y is 2 meters. So my delta y is negative 2 meters. This is very important, guys. This is what we know as the sign conventions. Okay, let's find out what the final velocity is. We respect the signs. Okay, this negative 2, you can actually see it like the final position of the ball is below the original position, so it is negative. That's another way to see it. That's the way I see it. I think, okay, the ball will end below its initial position, so my displacement is going to be negative. Now let's take a look. If you solve all this, you'll get square root of 36 meters square over second square. Negative and negative will make positive. 9.81 times 4, it's 39.24 meters square over second square. Now final velocity is the square root of 75.24 meters over second. So my final velocity is 8.674 meters over second. Now my final velocity, take a look, the initial velocity is going upward, but my final velocity, when it's about to reach the floor, is going downward. As it is going downward, the final velocity should be negative. Now that you already have your final velocity, we'll be able to find the time. How? Isolating from the formula. Okay? We have this equation, final velocity equals initial velocity plus gravity time. If we isolate for the time, we're going to have final velocity minus initial velocity divided by gravity equals delta t. Now my final, you know, is negative 8.674 meters over second. Minus 6 meters over second divided by negative 9.81 meters over second squared. When you solve all these, you'll see that delta t is going to be negative ounce minus 6 divided by negative 9.81, 1.5 seconds. That's it. Okay, here, another thing. For example, if you kind of forget that final velocity is negative because it's going downward, when you do all this, you'll realize that your time is going to be, sometimes it's going to be negative. But what happens? If your time is negative, that means that you're going back in time, but that's not possible, right? We cannot go back in time. So please be careful. Time it should always be positive. If you get a negative time, that means that you probably did something wrong. Let's do one more example. Robot Probe drops a camera off the rim of a 239 meters high cliff on Mars, where the free fall acceleration is negative 3.7 meters per second square. Find the velocity with which the camera hits the ground and find the time required for it to hit the ground. Now let's see. I did a drawing similar to the idea that is happening. Let's say this is the robot probe that is on Mars, and by accident or intentionally drops the camera off the reef. Okay. Now let's see. This time we're talking about an initial position right here on the top. As this cliff is 239 meters, we say that the initial position of the camera is 239 meters positive, and as it is being dropped, reaches the floor, or the ground, sorry. As it reaches the ground, if you remember in the last exercise, the ground is 0 meters. So the final position will be 0 meters. The final position will be 0 meters, and also when it says drops or falls, we say that it's implicit one given that is called initial velocity 0 meters per second. It's like from rest or something like that, okay, like we did before. So take a look. Drops or falls or something like that, words like that, tells you that the initial velocity is 0 meters per second. Now let's take a look. I'm gonna highlight the givens. I'm gonna write them. So first, as it says drops, I know my initial velocity is 0, and the high cliff has a height of 239 meters, and the free fall acceleration is negative 3.7. I'm looking for velocity with which the camera hits the ground. So I need to find the velocity in my final position. So my final velocity is the one I'm looking for. And when it says find the time required, I'm obviously looking for the time. Okay, I already wrote all the givens right here, as I mentioned before. So if I don't have the time, the only expression useful for this type of problem is the last one that says final velocity equals square root initial velocity to the second power plus 2 gravity delta y. Now here the initial velocity, as it says drops, I know it's 0. I don't need it. Now I need my delta y. As I told you before in the last exercise, delta y is y final minus y initial. The final position of the camera is in the floor, so it is 0 meters. Minus from the formula initial position, that is right here in the top of the high cliff, so it's 239 meters. So my delta y is negative 239 meters. Or the final position is below the initial, so it is negative. So my expression was reduced to this, and my final velocity therefore will be equal to negative 3.7 meters per second square, negative 239 meters. When you solve all this, you'll realize that is, I get the square root already, this is plus minus. 42.05 meters over second. Now, my final velocity is going upward or downward. Let's see. My initial velocity is 0, was not moving at all, and my final velocity is going downward, so this final velocity is negative. Please do not forget that. Now that I have my final velocity, I'm gonna be able to find the time. From the last exercise, we learned that the expression useful for finding the time is final velocity minus initial velocity divided by gravity. This is one expression, this is the other expression, okay? Let's see, negative 42.05 meters over second. This is 0, the initial velocity is 0, you don't need it. Divided by negative 3.7 meters over second squared. So my time for this exercise is 11.37. What does it mean? In seconds, of course. What does it really mean? That right from the moment the robot dropped the camera, it took more than 11 seconds for the camera to hit the ground. So that's what it really means. And at what velocity? 42 meters over second. That's pretty fast. If you do the conversion to kilometers per hour or miles per hour, you'll see that this is a really high velocity, 42 meters over second. Now let's do one more example. A flower pot falls from a windowsill 25 meters above the sidewalk. How fast is a flower pot moving when it strikes the ground? How much time does a passerby on the sidewalk below have to move out of the way before the flower pot hits the ground? So basically this is what's happening in this problem. Let's see, this is a building, a really high building, and we have a flower pot 25 meters over the sidewalk. Now, let's say a cat drops it by accident, of course. And how long is it, if you are here, how much time you have to move before the flower pot hits you in the head? And the other question is how fast, by having which velocity is going to reach or to hit the ground. And also another important word here, a key word, when it says false, as I already told you in the exercise before, means 0 meters over second. Now let's highlight the givens, and I'm gonna write them on the page. Okay, so we have the initial position of the flower pot to be 25 meters above the ground. Initial velocity to be 0 because it says false, just false, so that means the initial velocity is 0. Now my final position is right on the ground, on the sidewalk. So when that happens, remember the exercise that we did before. Here is 25 and on the ground is 0. So if it says ground, it's going to be 0. And if I want to know my delta y, just subtract final minus initial. So 0 meters minus 25 meters. Delta y is going to be negative 25 meters. Or that means that my final position of the flower pot is below the initial, it's going to be negative. Now, I'm looking for final velocity and time, but there's always an implicit given in this type of problems, which is the free fall acceleration. As we're talking about a building and a flower pot, we're talking about Earth. So gravity on Earth is negative 9.81 meters over second squared. Now let's do this problem. I want to know how fast it was going at the end, when it hits the ground. So in my first part, I will find the final velocity using the equation, very known equation, initial velocity to the second power plus 2 gravity delta y. You know we don't have initial velocity because it comes from rest or it falls. So we say that final velocity to gravity delta y. We just plug in the givens and we solve in the calculator. 2 times negative 9.81 times negative 25, 490.5. The square root of my answer is 22.15 meters over second. My final velocity, as it's going down, it's going to be negative. Please do not forget this negative from here. Now in part B, I'm looking for the time, and you know this expression is pretty useful for finding the time. It's final minus initial velocity divided by gravity. We don't have the initial, but we do have the final. Negative 22.15 meters over second divided by negative 9.81 meters over second squared. Please do not forget the negatives. And my final time is 2.26 seconds. So you have 2 seconds for moving before that flower pot hits you on the head. Okay. Well, guys, this is it. See ya.